All right, so the scientific method is, well, not necessarily always a part of the first chapter, but it is an essential part of any sort of chemistry class because or any sort of science class, because it basically tells how you confront problems and address them in a scientific and methodical way, hence scientific method. So basically the scientific method consists of the following steps. You identify a question to be answered. You devise some sort of hypothesis to explain that. You test that hypothesis. You collect data, and then after collecting data several times, you draw a conclusion. So as an example, for me in my life, I have 3 kids, and I kind of wonder, why don't they go to sleep exactly when I want them to go to sleep? So that would be my question. My hypothesis could be something like, maybe I'm not giving them enough Oreos around the time that I want them to go to sleep. So what I would do is I'd say, okay, day 1, I'm going to give each child 10 Oreos and see if they go to sleep right whenever I want them to go to sleep. And I would collect data after 2 or 3 days, and I'm pretty sure that I would conclude, no, in fact, they do not. But that would be kind of my data and my observations, and then subsequently my conclusion, where I would reflect on the data that I've collected, and I'd say, oh, lo and behold, if I give my kids 10 Oreos before bedtime, they do not go to sleep exactly when I would expect them to. Okay. So another thing, as is a key part of any sort of scientific course or any sort of scientific discovery, is you need to have a critical eye to identify basically bad science. You need to have you need to be clued into what to look for whenever you're presented with information, and be able to critically evaluate it and say, yes or no, this is good, or yes or no, this is bad. And so for spotting bad science, the first thing that I would say is, if any of my cousins or relatives shared it with you on Facebook, that's probably an idea of it being bad science. But I suppose there are some more broad things to say. For instance, a sensationalized headline. If there's a conflict of interest, so if somebody conducting research is being compensated by the company who they're evaluating, well, that's entirely possible. That's a source of a conflict of interest, in which case they're going to be influenced by the person giving them money. If data is not reproducible, if the data, or if the kind of publication is not peer reviewed, then it's not gone through the process of other scientists looking at it, kind of not blindly, but looking at it and evaluating it and saying whether or not the researchers drew all the appropriate conclusions from the data that they have. So this is just a series of different ways that you can look at scientific information and evaluate it critically. Now, whenever we look at any sort of pieces of matter or things, we always use the SI base units, the International System of Units, for looking at different quantities. For instance, length, mass, time, temperature, and amount of a substance. Our units are meters, kilograms, seconds, Kelvin, and mole. Those are symbolized by M, kg, S, capital K, and mole. All of these are units that we will encounter pretty regularly in this course. Length, not so much, but we'll see it a little bit when we're doing our evaluations of density. But these are all the units that are used in any sort of chemistry and science course. So another thing that's a key part of this class, whenever you're looking at numbers, is to look at the magnitude of those numbers. And we evaluate that with prefixes. So we looked at this 10 to the 12th. Remember, that was converting from a number depicted by scientific notation versus a simple formatted number. 10 to the 12th indicates that you're moving a decimal place 10 places to the right. So when you're converting from scientific notation to standard format, where are you moving your decimal place and everything like that. So tera, giga, mega, kilo, deci, centi, milli, micro, nano. I would say in this class, we're going to generally be living between kilo and micro. So that's 10 to the third to 10 to the negative sixth. So we'll have a lot of numbers where we're looking at, you know, conversion from a kilogram to a microgram. So make sure that you know how to do those sorts of conversions, which I'll get to a little bit later in this chapter. But that's kind of the range that we're going to stay within, kilo to micro. That's not to say the others will never surface, but I would be most comfortable with those. So those numbers that you just saw on the previous slide, we're going to get into a little bit more in a little while when we talk about something known as dimensional analysis. So I'm going to go ahead and take a pause on showing any sort of examples until I introduce dimensional analysis. But dimensional analysis is simply a way of converting quantities and converting amounts with exponents, and very easily doing it.